Hello everyone. In this video, we're going to be solving a nice system of ordinary differential equations. So x and y are functions of t, and we're given x prime and y prime. As you can see here, x prime is equal to y plus e to the power t, and y prime is equal to x minus e to the power t. So this is coupled. As you can see, we don't have the x's and y's separated, so we cannot directly solve these equations. In other words, x prime contains y and y prime contains x on purpose, obviously. But there's something that makes this equation really easy to solve, and I'll be presenting two methods. As I said earlier, I'm going to try to give you a differential equation or a system of differential equations once a week. As you know, my videos will publish or premiere on Mondays, Wednesdays, and Fridays. Wednesdays are for aplusbi in case you didn't see my new schedule. Great, so let's go ahead and see how we can solve this problem in two ways. So first method, I'm going to start with the first equation, x prime equals y plus e to the power t. I'm going to go ahead and differentiate this. My goal is to get y prime and then substitute. If you differentiate both sides with respect to t, x prime becomes x double prime, the second derivative, and then you get y prime. And since this is a function of t, e to the t becomes e to the t. Because again, we're differentiating with respect to t. Now, from here you get y prime, which can be replaced with x minus e to the t prime, right? And what does that give you? Well, if you do that, you're going to get x double prime equals x minus e to the t plus e to the t. E to the t obviously cancels out, leaving us with something super duper nice, which is x double prime equals x. Let's go ahead and subtract x from both sides and set it equal to 0. Now this is cool because from here we can get the characteristic equation, which is going to be r squared minus 1 equals 0. If you don't know how the characteristic equation works, you can just replace x with e to the power rt, and then you'll get the same one. Okay? How do we know that it's going to be in this form? Because that's the type of equation that we have here. So r squared minus 1 equals 0 obviously has two solutions, r equals 1 and r equals negative 1. Both of them are going to give us solutions. If you kind of split them up with two constants, you get the following. In other words, get a linear combination of the two solutions. You get x equals c sub 1 e to the t, which is 1t. That comes from r equals 1. And the other one is going to be negative 1t. And that'll be e to the power negative t. Okay? That's our solution. And since this is a homogeneous equation, this is the solution for x. If this wasn't a homogeneous equation, like let's say we had something like x double prime minus x equals t, then we would still solve the homogeneous equation. And then for the polynomial forcing, we would assume a particular solution like a t plus b, plug it in, and then find the values of a and b, and then add it to the homogeneous equation. Because the general equation is always made up of the homogeneous solution plus the particular solution. But since we have a homogeneous equation, this is the only solution for x, which is nice, right? We already got x, so are we halfway done? Well, let's see how we can find y from here. So if you remember from the second equation, we have that y prime is equal to x minus e to the t, right? But that's not what I want to use. Is that what I want to use? No. I want to use the first equation. And remember what the first equation told me, because I don't want to differentiate y, or I don't want to find the derivative of y. The first equation gave me x prime equals y plus e to the t. In other words, y was written as x prime minus e to the t. And since I have x, I can go ahead and differentiate it and plug it in to find y from here. So let's go ahead and differentiate x. We already got the value. If you differentiate c1 e to the t, it's just going to be the same thing, c1 e to the t. From this one, you're just going to get a minus 1 from the derivative of negative t. By chain rule, it's going to be minus c2 e to the power negative t. So that's x prime, the first derivative. And guess what? We're going to plug it in here. Okay? So y is going to be x prime, which is c1 e to the t minus c2 e to the negative t minus e to the t. Of course, we can arrange this in a nicer form, into a nicer form like this. Since e to the t appears twice, we can go ahead and actually put those two together, these two things, and write it as c1 minus 1 multiplied by e to the t minus c2 e to the negative t. Now, you could definitely replace c1 minus 1 with another constant like c3, but make sure not to use C1 because it also depends on the solutions for x. If you remember, x also contains C1 and C2, which I'm going to write the solution right now. So x was C1 e to the t plus C2 e to the power negative t. So they kind of depend on each other. If you change the value of C1 into something else, or C1 minus 1, then you also have to make sure that you change the second equation. But I think this is going to be good as is. So therefore, the solution is going to be made up of these x and y values. In terms of t again, because remember, x and y are functions of t. But this is just the first method, right? And this is not usually what I prefer for these kinds of equations, but this is a well-known method. You can differentiate and plug in. This doesn't always work, but it's a really cool method. Let's go ahead and take a look at the second method now. For the second method, I'm going to write down the system one more time. We have x prime equals y plus e to the t, and y prime equals x minus e to the t. Have you noticed, I hope you did, if you add these equations, e to the t will cancel out. It'll disappear, and that's a good thing. Why? Because when you get rid of e to the t, you will only end up with x and y and their derivatives, but best of all, you're going to get the same type of structure. Take a look at this. You have the x plus y and x prime plus y prime. What is that supposed to mean? Well, x prime plus y prime just means the derivative of x plus y, because if you differentiate a sum, you get the sum of the derivatives, right? So from here, we can use substitution. And for these kinds of equations, let me tell you, a general way to approach them is use change of variables. And what we're going to do is we're going to set x plus y equal to u. In most cases, we set u equals x plus y, and then something like v equals x minus y, and then we just go from there, okay? So under this conditions, u prime is just going to give us a u. Obviously, this is a super duper easy equation to solve, don't you think? Well, if you want, you can subtract u from both sides, and the characteristic equation is going to be r minus 1 equals 0. The only solution is r equals 1, which means u can be written as c e to the t. There's only one root, and sometimes you get complex roots. But again, using Euler's formula, you can write it that way and turn it into something trigonometric. And later on, we're going to do more complicated equations. I promise to give you more and more complicated problems. And at some point, you're going to be like, oh, this is enough. We don't want anything more complicated. We're going to go to insane levels, okay? That's what I'm planning to do. Anyways, so we got u, but that's not the whole purpose. If you remember, we set u equal to x plus y. So this means x plus y is equal to c e to the t. Let's go ahead and save it for now because later on we're going to use it, okay? Now, what's next? The next thing is we do need to have something for x minus y, right? Or, okay, let's just do this. Let me rewrite the equation so I can tell you what I'm talking about. X prime is equal to y plus e to the t. Y prime is equal to x minus e to the t. Now I'm going to go ahead and subtract these equations. My goal is to get something like x minus y. Negate, 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 and then add down. That way you're subtracting. X prime minus y prime is equal to y minus x. E to the t doesn't cancel out, but don't worry about it. It's not going to be a big problem. Great. Now we got something like x prime minus y prime, which is the derivative of x minus y, by the way, right? But on the right-hand side, we do have y minus x. What is that supposed to mean? No worries. We can just add x minus y to both sides, and that gives us this plus x minus y, because x minus y and y minus x are opposites, and we get what we want. Now, what am I going to do? I'm going to set it equal to v, so this is going to be v prime. Awesome. We get v prime plus v equals 2e to the t. Uh-oh. We did not get a homogeneous equation. That's fine. We can still solve it because the homogeneous case is super duper easy. So you can kind of do this. You can go ahead and set this equal to 0 and find the homogeneous case, and then find a particular solution, which is probably going to be in the form of a e to the t plus b, right? Most probably. Sometimes you have to try something like t to the t, but I don't think that's the case here. And then you can kind of find a and b from here and just add it to the homogeneous solution. But there's also another way which I think I should talk about, and that's called the integrating factor. The integrating factor is usually, you look at the coefficient of v, I believe. It's 1, and then you raise e to the power that integrated by t, which is 1 dt, and that'll give you e to the t. Great, don't worry about the constant. So what does that mean? Our integrating factor is e to the t, which means if you multiply both sides by e to the t, this is going to be an exact equation, which means it's going to be the derivative of a product or a quotient in some cases. So let's go ahead and do that. I'm going to multiply by e to the t, but I'm going to do it in such a way that I kind of switch sides a little bit here in the product. And of course, this is going to be 2e to the 2t. 2t or not 2t if you're a tutor, right? That's the question. Now, take a look at this. What is that supposed to mean? Well, the derivative of something times e to the t, and then the derivative of e to the t times something. That is the product rule, or the derivative of a product. So in other words, this is the derivative of v times e to the t, which is what I mean by exact. Now you can go ahead and integrate both sides with respect to t, and you'll get v times e to the t from here. Of course, when you integrate, you have to consider the chain rule, but we already have a 2 there, which is good. So the integral is just going to be e to the power 2t. Of course, there is a constant in this case, so we're going to have to add that. Let's just add that as C2. I don't know if we use C1, but that's okay. Doesn't matter, no big deal. Now, of course, our goal is to solve for v here. So let's divide both sides by e to the t. That's going to give us e to the t plus C2 times e to the power negative t. Because C2 is a constant, we have to multiply by a negative power, right? Wait a minute, did I multiply both sides by e to the t? No, I'm dividing by e to the t or multiplying by e to the power negative t. Does that make sense? I hope it does. Now, we got v, but v is what, right? Well, v is x minus y, so this is x minus y, e to the t plus c2 times e to the negative t. Okay, let's go ahead and bring u here, which is x plus y. X plus y is c e to the t. X plus y is c e to the t. So what are we going to do? From here, we're going to definitely add these equations and divide by 2. That's going to give us the x value. And then we'll subtract this way because you want y to be positive, obvious, right? And then we're just going to get the values. If you don't like this, you can put the x plus y first. And then that way, well, let me do that real quick. No big deal. All right, let's go ahead and do it that way so you don't have to switch them. And then we can now subtract. Okay, this is x plus y. And I can now get rid of this. I don't need this. Okay, cool. Now, let's go ahead and take these two equations together. We're going to add them first. When we do, y is going to cancel out. We're going to get 2x, and upon division by 2, you're going to get the value of x. You can also do it this way because we know that u is x plus y and v is x minus y. X is just going to be from here, u plus v divided by 2, and y is going to be u minus v divided by 2. You can also approach it that way, same idea. But when you do this, all of that thing, x is going to be c to the t plus e to the t plus c2 e to the negative t all over 2. And y is going to be u minus v divided by 2, which is c to the t minus e to the t minus c2 e to the negative t divided by 2. Now, your goal is to turn this into what we got with the first method. By playing with the constants, hopefully you can get the same thing. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video, and next week with another differential equation or system. And until next time, don't forget to check out aplusbi, and bye-bye.